All right. Well, it is. I think today's Tuesday. Does it feel like a Tuesday to you, Justin?
Feels like a Tuesday to me.
Okay.
Yeah.
All
Smells
right.
like a
I mean,
Tuesday too.
yeah. I mean, it's close enough for government work. Well,
I think
good
so.
afternoon. Actually, is it still morning for you, or is it
So I'm
afternoon?
in Las Vegas right now. I'm not in my typical place. I'm
Right.
here at the Gartner Application Summit, which is a different conference that I typically
Different
go to.
beast. Right.
Analyst relations fall under some of my responsibilities. So it's 11
Gotcha.
o'clock. So it's
Okay.
like
Well,
that. I
good
guess
morning then.
like a
Good
Vegas
morning. I think.
morning, isn't it?
I
That's
mean,
like
in Vegas, that's like an early morning, I
yeah,
believe.
it's like people just getting breakfast and yeah.
Right. Just rolling in from the casinos. So
That's
so
right.
well played, Florida man. Well, Justin, thank you so much for being with us here today, my friend. It is a delight as always. We were talking in the pre-show that you and I've been kind of like crossing each other in airspace and going one place to the other. So fingers crossed, you and I are going to be in the same space physically again very soon. I miss hanging out with you, buddy. But I am so happy that you're able to hang out with us here today and talk a little bit about how we can be more productive at this whole game, right? I mean, I hear there's a way to be like 10x. So what
Mm.
what can you do to help us here? And I will point out that Justin wants questions as we go. So I will be lurking and I will reappear at points with questions from you, the audience. So if you've got something that you would like to ask Justin, take advantage of it. Just throw it into your comment box there. I will see it, and then we'll see what kind of trouble that gets us into. But what do you think? Should
Awesome,
we do
man.
this?
I really appreciate it. As always, great to see you. And likewise, we've definitely got to cross paths in physical space sooner rather
Heck
than
yeah.
later. So,
Heck
yeah,
yeah, buddy. All right, well, let me bring your slides in here,
perfect.
and I will drop off for the time being. But hey, I might be springing back in. We'll see. Give me a reason to jump in on Justin here, friends. So,
Yeah, for
all right,
sure. I love it. It keeps me, especially with these remote talks, it helps keep me engaged. Reminds me that there's people listening. So I appreciate that.
right,
Okay, so as
exactly.
Nate mentioned, we're going to talk about 10x developers, but we're going to start, with kind of an acknowledgement that that individual 10x developers don't really exist, and I have some compelling data to behind that. My name is Justin Reock, Field CTO, Chief Evangelist at Gradle. My background is primarily in software development. I spent a long portion of my career writing code, but now I focus mostly on new methods of productivity, especially developer productivity engineering, which we'll talk about in this talk as well. So let's talk about the 10x engineer. When it comes down to this particular definition, as in the developer in the organization that is 10 times as productive as other developers within that same organization, I think of it in the same category as the Yeti or the Chupacabra or the mystical centaur or magical unicorn. And I apologize if you actually do believe in any of these. I'm not trying to alienate, but I do think that they're relatively well established as mythological characters. And I absolutely think the 10x engineer is a mythological character as well. And I have some data behind that. But there's a kernel of truth to any myth, right? And I think that in this case, we can point back to a really interesting study that was done in the mid 80s by Tom DeMarco, Timothy Lister, called the Coding War Games. And there's some really compelling data that came out of this study that I think is still very much relevant to the way that we think about productivity and developer experience and their relationship today. So you can pull up if you want to see kind of like the white paper abstract of this. There's also a book that I'm going to recommend in a minute that's centered around this study. But the long and short of it was that they took multiple developers from the same organization and they gave them a business task. And the task was the same for everybody who took place in this study. And there were almost 100 different companies and 600 developers, over 600 developers that took part in this study. They gave them all the same business task. And they said, just complete this task and keep track of how long it takes you to do it. Now, the important things to take away from this, multiple companies were competing with one another, but the programmers within that same company, they were not working as a team. Right? They were competing against each other as well. So everybody was working on this task individually. So it's not paired programmers. So it's single developers working on the same task. And there was no mandate as to what framework or language you were supposed to use, just whatever you're comfortable doing, right? So they did this. And again, over 600 developers took part, over 100 companies took part in this. And some really interesting outcomes came out of this. This is the book, by the way, Peopleware, which is centered around this study and a lot of other very compelling data on how to build highly productive software teams. I do recommend this book, even though it's an older book. It's in its third edition. I still think it's one of the best books kind of dedicated to the the idea of building highly productive software teams and based on data. So here's what happened in this study. The best programmers outperform the worst by roughly a 10-to-1 ratio, but it gets a little bit more interesting than that. There's a little bit more to that story. So, but this is where I think the 10-1 came from. Before that, there's a couple of very interesting non-factors I thought that are worth calling out here as well. First of all, so some things that didn't seem to impact productivity. Language. Okay, with the exception of our assembly developers or poor assembly developers, they definitely took a little longer. But for the higher generation languages, it really didn't matter. Whatever they were comfortable in didn't seem to move the needle in terms of productivity. Bitter pill to swallow on this next one, years of experience. People with 2 years of experience were performing at roughly the same productivity rate as people with more than 10 years of experience. So that's an interesting case. It dropped off at around the 6-month period. Number of defects. Okay, so are they just cranking out, crummy code full of defects, but they're doing it quickly? No. The top performing developers in this study actually created defect-less code. And another bitter pill here, salary. The top performers were only making about 10% more than the bottom performers. So let's see what did matter, though. So paired programmers from the same organizations, right? So programmers working within the same organization, they performed at roughly the same level. There was only about a 21% difference between participants working within the same organization. And if you think about that 10x differential between top and bottom, that 21% becomes a rounding error within a standard margin of error. It's just statistically insignificant when you look at the breadth of difference in productivity. So really, people within the same organization were performing at kind of the same rate. However, the best organization performed over 11 times better than the worst. So organizationally speaking, there was definitely an order of magnitude in difference between the organizations that were highly productive and those that weren't. So Harlan Mills, a computer science professor, actually from my home state of Florida, looked at this study and came to the conclusion that while this productivity differential among programmers is understandable, there's a 10-to-1 difference in productivity among software organizations. And you can see the outcome of this study here at this URL. So to sum this up, the best performers are clustering in some organizations while the worst were clustering in others. Some companies were doing a lot worse than others. And there's just something about the environment or corporate culture that fails to attract and keep good people or makes it impossible for good people to work effectively. Now, let's look at some of this data, all right? So the top performing companies, they answered these questions a little bit differently, right? You'll notice some patterns here. How much dedicated workspace do you have? So the top performers had 78 square feet, while the bottom performers were down at 46 square feet. 57%, almost twice as many people in the top performing quartile said that it was acceptably quiet where they work. Only 29% in the bottom performers. Is it acceptably private? 3 times as many people in the top performers said yes. 5 times as many people in the top performers were able to silence their phone. And these are those big, chunky conference phones for those who've been in the industry as long as I have, but you could still silence them. Diverting calls, 76% said that they could do this, where only 19% in the bottom performers said they could. And do people often interrupt you needlessly? 38% in the top performers said yes. We're twice as many in the bottom performers said that they were interrupted needlessly. So sorry, Slack, you're not making us more productive here. We can prove it. But really, what does this say? The phrase hadn't been coined yet, but at the end of the day, increased productivity just came down to a better developer experience. So 10x organizations can be manufactured, all right, not born. They're done through intentionally paying attention to developer experience, removing impediments to productivity from those developers, and focusing on developer joy, right? And so that's what we're going to talk about. And this matters even more now. 2020 study from IDC predicted that 65% of the global GDP would be digitalized by last year. And that came through. The 2023 report isn't out yet. As soon as it's out, I'm going to update this slide and see where we're at. But this is already staggering. 2/3 of the global GDP is held up by software. All right. So we've got to focus on developer experience and improved joy and productivity. But we're still not even aligned on the way we talk about productivity. Some of you may be familiar with the SPACE framework. If you're not, you should definitely check it out. Work that came out of the people who started DORA, specifically Dr. Nicole Forsgren, who is one of the foremost thinkers on this subject. She and her colleagues invented a normalized framework for gauging productivity within an organization. And it focuses on these 5 dimensions that you can see in front of you: satisfaction and well-being, which is self-explanatory; performance, which means are we meeting deadlines? Are we getting vulnerabilities closed fast enough? Activity, lines of code, what are we cranking out? Communication and collaboration, and efficiency and flow, right? So these are 5 dimensions, and they should be in balance. And what I really like about SPACE framework is that it's normalized. There's no prescriptive way to get this data. You can literally just go ask questions of your developers and say, how do you think about productivity? And see how they answer. Categorize their sentences, their individual sentiments that they come back with into one of these 5 categories, and see how balanced you are. So when this was done in April of 2022, we came up with some results that are a little bit disturbing, that tell us that we have some real opportunities for aligning better around productivity. The same question that I just mentioned was asked to developers and managers. And this was, again, an April 2022 study, so not that long ago. Developers were asked, when thinking about your work, how do you define productivity? Managers said, when thinking about your team, how do you define productivity? Look at these answers down here, all right? Overwhelmingly, managers are defining productivity in terms of performance, whereas developers are defining it in terms of activity, right? So developers are thinking about number of builds and code that I'm cranking out, where managers are thinking more about deadlines. And this is actually what bothers me the most, though, is this top line. Single-digit concern for satisfaction, right? I think in any other industry, you'd see much more attention to this. But for whatever reason, as software practitioners, I think we've gotten used to having to have a hard time in terms of our tool chain and in terms of our experience and in terms of our management not always understanding our pains, right? And so this is a real opportunity for improvement, is to align on the way that both developers and their managers think about job satisfaction and just enjoying the work that they're doing, and then aligning way more on performance versus activity, right? The goal here is really to see a balanced response across all 5 of these dimensions. So we can conclude that I think that DevOps, 12-factor, Agile, all these things that have helped push our industry forward, they still haven't captured all of the bottlenecks and frictions and friction and obstacles to throughput and impediments to developer joy. So many are still hiding in plain sight right in the developer experience. So a 10X organization should be intentionally and with a focused way, an actionable way, thinking about reducing build and test feedback cycle times, and overall just improving the consistency and reliability of builds, right? We have too many problems still in our tool chain that create frustration and slowdowns for developers, and we have the right types of techniques and tooling to fix this. We just need to be mindful of it, and we have to start really focusing on it. Because at the end, when we know this, the only initiatives that positively impact performance are ones that increase throughput while simultaneously decreasing cost. So this is not just about reducing the overall energy that goes into producing software. It's really about how do we do that while at the same time increasing the throughput, allowing our teams to actually push out more while not leaning on them to work harder and not forcing 60-hour weeks, but rather focusing on the tools that they're using, treating that production, treating the development environment that they're working in as a production environment where developers are writing software. And having the right type of telemetry and data to figure out what that experience really looks like so that we can focus on fixing those bottlenecks. So it is time for developer productivity engineering, which is the focused practice that puts the developer front and center, and that makes sure that the technology that they're using, the build tools that they're using, the testing frameworks that they're using, the CI that's part of their cycle, that all of these things are as optimized as they can possibly be. And it borrows on these other practices. It borrows on these practices that have famously decreased costs while simultaneously increased throughput, and therefore improve the productivity practices of other businesses. So starting and leaning into what I love to call the ancient business wisdom of the 70s and 80s, we had things like just-in-time manufacturing and business process reengineering that would feed into change management when the world was all about manufacturing. But then when software ate the world in the late 90s and early aughts, this became Agile and Lean Six Sigma and ultimately DevOps. We're seeing this interesting glue in platform engineering right now, coming out of DevOps, but kind of making way for developer productivity engineering. So if you look at some of the companies that have been doing DPE at scale, like the Netflix, the LinkedIn, the Twitters, a lot of their employees went from DevOps SRE to platform engineering to productivity engineering, right? So we're seeing this play out, from a microeconomic standpoint, but we're also seeing, I think, the broader winds of the industry really start to focus on developer experience and really start to realize that a huge part of this experience is just making sure that developers aren't dealing with frustrating tools. So when we talk about DPE, we have to focus on the core value of DPE, which is that software development is a creative process, right? It is a craft, right? It's not like other types of more scientific work, right? This is absolutely engaging both the left brain and right brain activity. We understand as developers what it means to be in a state of creative flow, and that's ecstatic for us, right? That's what contributes to our joy, which then contributes to our productivity. We don't see a difference between developer joy and developer productivity at Gradle. Again, it's one of our very core values. We think that joyful developers are more productive developers, and more productive developers, by way of loving their craft, are more joyful developers. So if you put yourself in the shoes of these kids, maybe they just wrote their first Hello World program, right? System.out, println Hello World, or just println Hello World if you're doing Kotlin. But they did that, they hit go, and it flashed up on the screen. They got their feedback instantly, right? They immediately saw that what they did worked, and it gave them a bit of a dopamine hit and got them excited to move to the next thing, right? And what is developer experience but a combination of all these feedback cycles, just one after another, right? And when they're instant, when they're coming quickly, when we get the information that we need from the tool chain quickly, we're having a great experience, right? This left brain, right brain activity, you could think of it as a combination of creative problem solving and then having a scientific dialogue with the tool chain. On the one hand, we're envisioning a problem that we need to solve, and we're coming up with what that solution looks like. And then we do something very interesting. We make a hypothesis as part of our dialogue with the tool chain. We say, okay, I think that this code is going to solve this problem. And then we wait. We wait to get the feedback from the tool chain. And this feedback cycle time is where the experience all begins, right? So these kids are happy because they got their feedback instantly. They ran a short, simple program that flashed up the results on their screen, and it was joyful. But if you could imagine that these kids are waiting 30 seconds or a minute or 10 minutes or an hour for this feedback to occur, right? They're not going to look like that. They're going to look like this. But this is unfortunately what a lot of us are dealing with. But these kids are going to go find some other hobby, right? And we just have to get out of this. I mean, this is actually sort of a aspirational calendar in some ways because there's not a lot of meetings on this calendar. But look at what's happening here. We start. We're in our flow state. We're experiencing creative flow. We're coding. We're doing what we want to do, and then we're waiting for our local build to complete, and it failed. And we're going to debug that failure. And that alone is not enough to bring us out of a flow state. Just because the build goes red, that's just another problem to solve. No problem. We love solving problems. But if we're doing this for an hour with not enough data and blind spots in maybe our CI where the build has failed or something like that, or just blind spots in the reason that the build failed in the first place, and we're having to play 20 questions and hit up build engineers via Slack, that's not flow state, right? That's frustration. So we go to lunch, maybe we played some Elden Ring or New Zelda, if that's more your jam. And then we're back to coding, and we're in our flow state, and we're waiting. But this time the build completes. It's great. So then we pass it to CI, and we wait again for CI to do its work. Oh, and look, tests ended up being flaky. The tests that were succeeding in our local environment are failing in CI. And so now we get to do what we all love to do, spend the rest of the day fixing flaky tests. Again, it is 2023. And we owe our developers a much better experience than this, and we can bring it to them. We got to get out of this, right? This cartoon, I think we all have seen it a million times at this point, probably. There's even some productivity companies that have licensed it, put it right flat on their homepage. But this cartoon, it's important to understand that it's funny, but also really sad at the same time, because it's true. This is an excuse for legitimately slacking off. Oh, my code's compiling, right? I think we can say this now too. Right. We know that especially for larger enterprise applications, a significant portion of the cycle time, up 90% or more in some cases, is just in the testing phase. So we need to think about how we can speed that up and also make it more reliable. Right. I have a sinking feeling that we might be getting here. I hope not. We will see. But I'm certainly using this thing more than I would like to admit. So we'll see if we end up getting there. So let's start solutioning this. I think we understand the problem. Cycle times are too long, builds are inconsistent and unreliable, and we need to look at how we can address this. So if you can imagine on your left here, you sort of have a developer, and these things, and this could be a local environment, remote environment, CI environment, and these things surrounding the developer are feedback cycles, right? Sometimes things are fine. Sometimes they take too long. We've talked about that already. Sometimes they take too long to fix. Right? Again, playing 20 questions with the tool chain. And sometimes, this is the worst one. Sometimes if we had just been observing things like flaky test rates, like failure rates, then we could have proactively done something about this before the developer even ran into that bit of frustration, right? So this is actually my favorite part of what we can address with DPE. So not to spend too much time, but I want to point out some things that are maybe not always so obvious about why fast feedback cycles are so important. So we know, and let's do it in terms of what we see in terms of new behaviors and outcomes for the business. Well, we know that faster feedback cycles leads to less idle and wait time. That one's obvious. But this really means less context switching, right? If we have 15 minutes while a build is completing, chances are we're not just going to sit there, right? We may be attempting to go look at email or even checking a news feed or something like that, right? But we're switching tasks. And we're not very good at this as humans. Like we've determined over the last decade that we can't really multitask effectively. It takes anywhere from 10 to 12 minutes to really pay what we call a context switching tax, to go from one task to another. But over the last couple of years, we've learned something even worse. And that is that not only can we not really do this effectively, but that increased context switching is actually deleterious for our executive functioning. It's associated with an increase in glutamate in the prefrontal cortex of the brain, which is directly associated with cognitive fatigue. And the issue here is that cognitive fatigue is really slippery, right? You can still do your work while you're fatigued. We've all done it, but you can't, it's really, really hard to elevate that work. It's really, really hard to innovate and think about the next vision for that software if we're cognitively fatigued. So there's a direct impact on the innovative capability of a business, which means that there's a global impact on how fast the world can innovate, all based back on faster feedback cycles. So this leads to more focused developers, better quality, better productivity. We don't always think so much about the fact that if our builds are faster, if we can rely on a 10-second build, a 20-second build while we're making incremental changes, then we can build more frequently, which means we can have earlier quality checks because we're introducing smaller change sets, which means fewer merge conflicts downstream, more efficient troubleshooting, a faster mean time to resolve, which directly impacts quality and productivity. So we don't always think about the full cascading impacts of faster feedback cycles, but we should. So, okay, a lot of theory and hopefully some waking up to these new sets of problems that we really need to address. Let's talk about some solutions here that we recommend. First, build caching. Build caching is available in a number of different build tools. It is not a dependency cache. So let's be clear, this is not JFrog or Artifactory. This is not Sonatype Nexus or one of these dependency management solutions. These are very important. We want good dependency caching and dependency management to improve our dependency download times. It's absolutely part of the feedback cycle, but that's not what we're talking about here. The build cache is actually caching individual tasks for Gradle builds, for instance, goals for Maven builds. The best thing to do here is to just look into your build toolchain and see if this is available to you, right? It was introduced to the Java world by Gradle in 2017, not turned on by default, by the way, in the Gradle build tool. You do have to actively turn it on, org.gradle.caching equals true in your Gradle.properties. Maven introduced an open source build cache that's been generally available since October, which is definitely worth looking into. Of course, we offer one as well through Gradle Enterprise, but used by leading technology companies like Google and Facebook, and should be able to support local and remote caching. Again, just how it works, kind of 10,000 foot view. When you're dealing with a build system, individual tasks or goals or phases of that build have specific inputs that get sent in, and then they create specific outputs. So it could be an input of source code files that's creating a file tree of compiled class files. It could be an input of a test task that is looking for some type of JUnit XML report or something like that. But it's going to have an input and an output. And if we can create a hash from these inputs, then we can reliably and safely store those outputs in a cache and pull them from cache as opposed to rerunning that part of the build. So just a quick overview here. If you could pretend you've got a 4-module project, and these arrows indicate module dependencies. So you can see we've got a core module. The export API depends on the core module. Service depends on the core module, and web app depends on service, and nothing depends on export. Nothing depends on web app. If we were running a Gradle clean build, and Gradle does have its incremental build system, but that's ignored when we do a clean build. Or if we're doing just any Maven build without using any of the reactive Maven stuff, then any change is going to require that we run all of these tasks, all the compile, all the test compile, all the running the tests, all the check style. But if we're using a cache, Let's say that we change a public method in the export API module, right? Well, nothing depends on export API. So we only have to run test compile and then test and check style. And we can pull everything else from cache, right? So you can see that there's enormous possible time savings here. Or what about an implementation detail of a method in the service module? Well, we do have to recompile service. We changed an implementation detail. We do not have to recompile the test because it's an implementation detail, not a public method change. And so, so we don't have to recompile the test. We do have to run it. We have to check style because we did change the code. And there's a dependent module, the web app module that's dependent. We have to run its tests, but all the rest of this stuff we can pull from cache. So right there, we get some immediate savings. And remote build caches are available too, which work really well for distributed teams where, follow the sun model, for instance, people could be checking code into a CI that's shared against the new source code, populating a remote cache with the same type of entries so that a developer's first build of the day doesn't have to be an hour long, like, oh, the first decision of the day, I will wait an hour for my new feature branch stuff to come in. Instead, you can benefit from the cache immediately and realize very fast builds first thing in the morning. Okay, so that's one is build caching, but we combine these with some other techniques. We can get even faster. We can establish sort of a force multiplier effect here. And one of these is a technique called test distribution, which is not hard to build, especially nowadays that we've got really easy elastically scaling substrates like Kubernetes. So in this model right here, in this functional model, we're effectively taking whether local builds or CI builds. The important thing here is that we tie this directly to the build tool, right? We're not going to tie this to CI and limit where it can be used. The local build or CI build can schedule tests to run on remote agents in parallel in an elastically auto-scaling way. So for instance, these could be stripped down Linux containers with a JVM installed that are capable of running JUnit tests. And we have some sort of auto-scaler, like for instance, a horizontal pod auto-scaler in Kubernetes that's able to schedule these tests across these agents and allow them to run in parallel. It's better than solutions like CI fanout, which attempt similar things here. So this would be a configuration for CI fanout where we've manually partitioned some groups of tests and we're running them as a parallel stage pipeline, as a parallel stage in the pipeline. But this is bound to CI, so it wouldn't work locally. And we have to manually partition these test sets, and we have to figure out how to reconcile the results of these, right? So, build caching is great, but it doesn't help us when test inputs have legitimately changed and we need to rerun those tests. If we were trying to run more parallel tests and stuff locally on our machine, we could do that, but we're going to be limited by those resources. And CI fanout doesn't help us during local development, and it requires manual setup and all these things that we just mentioned. So test distribution gives us a much cleaner, more elegant way to run these tests in parallel. If you're interested in a case study here, Netflix was able to reduce a 62-minute cycle time down to just under 5 minutes using just build caching and test distribution. So you can imagine that has like fundamentally changed the way that Netflix has been able to work on this backend Java app. And we'll get these slides out, so don't worry if you don't grab the QR code fast enough. And then our third leg of what we really recommend you be looking into right now in terms of build feedback cycle time acceleration. Notice that this is the Gartner use case prism for adding AI to software development and testing. And there's a lot of different areas where AI is going to contribute. But we're speaking right now, this one subject around two things in particular: test set optimization and optimal test selection through a technique called predictive test selection. Predictive test selection was born in the labs of Google and Facebook published this paper in 2019, which you can check out. It's got a full blueprint for building a predictive test selection engine off of the open source XGBoost learning library. So notice if you're familiar with that library, that is a gradient boosting algorithm. It is not deep learning. So you can add AI to help optimize your test set without having to like install a GPU or something like that, right? This works on just a normal CPU. And effectively the way that it works, if you look at how a conventional test selection works, if you could imagine that this is just a dependency tree or dependency graph, and down at the bottom, let's say in red, we made changes to these two modules, right? Well, conventional testing will say, okay, run all of these tests that are potentially impacted by these two changes that we've made down here, right? So it's a very like conservative approach. you know, in that we're just making sure that, you know, no matter what, if there's any possibility that this test could have been impacted, that we run it, which sounds like the right thing to do. But predictive test selection allows us to do something a little bit more interesting here. We can build a learning model, which we can train on various features of the tests that are running and the inputs to those tests, so source code files and things like that, down to even file name extensions and typical failure rates. And we can use a learning model to predict whether or not, given a certain set of inputs and circumstances, the test is likely to provide any valuable feedback. In other words, you know, if it's been succeeding, is it going to fail? And if it's not likely to provide any valuable feedback, then don't bother running it, right? At least pre-merge, right? Be very careful here. Post-merge, we want you to run all your tests, but pre-merge, making incremental changes, especially in your local testing environment, this can be a huge time saver, right? You can just filter out massive amounts of tests that just aren't necessary. And let's face it, like, we already do this. Like, I know you do. Like, we already go through and turn off tests that were like, oh, I don't think I touched that part of the code. We're not going to run that test right now. So at least now you have a learning model, which with a predictable confidence that and explainable rule set that you can use to optimize the test set. Okay, so those are kind of the three legs of the acceleration technology. So you can imagine build caching hits us first. What can we skip? What can we just legitimately skip and pull from cache? Okay, great. Now predictive test selection comes in and says, well, how can we optimize these tests that we still think we need to run? We can't pull them from cache, but are they really going to be valuable for us? And then finally, whatever's left can be distributed in parallel, right? So we're talking like 50, 60, 70x gains in a lot of cases. But that's just the build and test cycle time speed. We also mentioned that there's still some other problems that we need to deal with. So how about troubleshooting? And I'm talking about not really debugging here, but troubleshooting a failed build, right? Build goes red. What happened, right? We won't go too deep into this, but if you'd like to see what all goes into what we call a build scan, which is a freemium service that's offered by Gradle, and it's offered for Gradle, Maven, and Bazel, soon to be SBT. And I'll show you a link where you can try that. Spring has also been using Gradle Enterprise for free for a long time. We made a donation. We have a really strong partnership with Spring, and they've been using our technology for a long time. So if you're curious, you can go to this ge.spring.io link. This is just the public Gradle Enterprise dashboard for Spring, and you can see all the build scans that are in there, and you can see all the data that we recommend kind of harvesting per build to improve your overall troubleshooting. This is all data that, you know, could be gleaned from various sources, things like, you know, infrastructure details, like what JDK and what operating system, you know, switches, like what build configuration switches did you use, a full dependency graph. Obviously, you can get all this information from different places, but as you'll see, I think in this interface from a troubleshooting perspective, it's really handy to have it all in one place, right? So even if you don't end up using build scans, at least I would recommend taking some inspiration to figure out, you know, what data has been really important to help speed up troubleshooting and see if you can replicate that in some way. This is just a same listing, except these are all individual build scans that have run. So you get this kind of nice view here of, you know, what's you know, succeeded and what's failed and that kind of thing. So, and then, yeah, the freemium service is available here, scans.gradle.com. You'll run your build, and then you'll get this nice interface with all this additional data. We absolutely have customers that build this into their automation, and we have people who have shamelessly, you know, used our free tooling too and put it in their automation, and they get what they need in terms of being able to expedite troubleshooting for their builds. So check that out. But that's still not the end of the story, because if we don't continue to focus on the reliability of the tool chain, problems are going to sneak right back in. Right? I mean, simple changes like upgrading an annotation processor could add seconds to our build time. Compiler settings, memory settings, it usually doesn't happen all at once, right? It usually like, oh, we added 5 seconds here, we added 10 seconds here, we added 30 seconds here, and before you know it, a build that was taking 15 seconds is taking 5 minutes, right? You need to keep track of this stuff over time, right? 10x organizations are absolutely tracking the build time of every single build, whether locally, remote, or in CI, and putting it on a graph so that they can see trends, right? Because you can observe a lot by just watching, but there's so much that we're not watching. I ask this question, and if you're a Spring Boot or Spring Framework developer using Gradle Enterprise, you are doing this, but that's because, you know, you've been ahead with the DPE stuff for a while. But when I ask this question to audiences of hundreds of people, I mean, I just was at keynoting DevOps Days, Birmingham, Alabama, a sold out audience keynoting DevOps Days Zurich. just a couple of weeks ago. 350 people in that audience. And I asked this question and maybe 2 hands went up. But this is like the most important metric for understanding developer experience. And it's not difficult data to get. So at this point, I really like to sort of make the appeal that if you kind of come away from this talk doing one thing, like figure out a way, whether it's creating a small plugin for your build system or whatever, to pull this one bit of data out in every environment and put it on a dashboard somewhere. Just how long are developers waiting for locally for builds to complete, right? Just start doing that one thing, because if you do that one thing, you're not going to be able to unsee that one thing, and it will lead you to more focused productivity efforts within your business. So yeah, tracking build and test times, these each bar here would be representative of a single build. And this allows you to spot trends, right? Trends in whether the build was, 5 seconds on Tuesday and 5 minutes on Thursday. Well, now we know that something regressed and we can look into it. This gets us out of us asking the wrong question, which is the cycle fast enough? This is the wrong question to ask. We now owe our developers a new question, which is the cycle as fast as it can possibly be, given all acceleration, technology, and analytics, because that is what our developers deserve. Okay. And so we need to be able to trend this stuff. It should be no surprise that when we survey people who are actually, doing DPE at scale, we get, very positive returns that yes, that the DPE just makes their job more enjoyable. And it's not like the other 19% were like, no way. It was more like a don't agree, disagree, don't know what DPE is, not really engaged with the question. But we tend to get these types of results that, yeah, it fosters developer joy to put these practices in place. It's also very important to eliminate avoidable failures. Do simple things like tracking failure rates. What you're seeing here is just a dashboard that says, okay, this one failure with this one stack trace impacted 18 developers over the past week across 247 hosts. 1,230 builds over the last week failed with this one failure. It helps answer the question, if you've got an hour to improve your build tool chain, where should you spend that time, right? Well, if you have data here that shows you the impacts of problems with the build, then you can make that decision with data and have the biggest impact possible. And we must do the same with flaky tests. I know that this is what we do now. Test is flaky, we try it again, we rerun it again, we reschedule it in CI, and then we ignore it at the end of the day and just approve the pull request. We do this, right? But there are ways to detect flaky tests and put them on dashboards. You can write a small plugin that has them, a failed test, have it run again and see if it succeeds, right? It's a little bit more overhead, but over time, as you start eliminating that flakiness from the tool chain, you end up with a much more reliable and trustworthy tool chain and really better morale. And at the end of the day, all of this helps to improve CI too. All of it really working together. You have a more consistent, reliable build tool chain. You have tests that are not flaky, so you're not scheduling them 10 times in CI over and over and over again. You have build agents that, although the developers may be scheduling builds more frequently because they're faster, those individual builds, the resource from CI is more valuable because you're doing more with that agent at the time, right? So all of this will have a very positive impact on CI. From a support perspective too, using those build scans to foster sort of developer self-service and troubleshooting in general will mean less tickets going to your DevOps engineers for failed builds, because developers will be able to assess and troubleshoot those failures on their own. Okay, so all of this is to say that DPE will become standard practice. The world should foster developer joy. The time is right. And we have the techniques. We just need to focus on them and start adopting them. So a couple of quick next steps here. If this was interesting to you and you want to kind of learn how you can start bringing this stuff in, the organizations that are doing this the best, like the LinkedIn's, Twitter's, SoundCloud's, Elastics, they've all built Spotify. They have all built focused teams, all right? Focused teams who do nothing but focus on developer productivity. This underscores one of the differences between DPE and DevOps. The ultimate platonic ideal of a DevOps team is no team at all, right? All bots and all automation. But I think for a DPE team, it's really important to have folks with a deep empathy for the developer experience. Otherwise, you just don't get the sense of urgency in putting these practices in place. So important to have a program managed office, whatever you want to call it, a center of excellence around developer productivity. Even if it's only a few people at first, these things can grow. Uber has a team of 300 productivity engineers, all dedicated on just productivity for the larger team of engineers. And the same is true for a lot of these highly scaled productive organizations. Okay. Also, I'm pretty excited about this. This is new. We just piloted it a couple of weeks ago at the Atlanta Java user group, last week at the Atlanta Java user group. If you want to learn more about DPE in a vendor agnostic way, we're taking you through materials that are not sales pitches for Gradle Enterprise, right? These are materials that show you the various techniques and how to assess your current organizational maturity. If you want not only a free way to kind of go and have sort of a knowledge journey to take you, through this DPE material, it's not only free, but you actually get rewarded for it, right? For you to get points for going through the first set of challenges, like a lot of points. You get like 2,000 points for coming into the platform, and you can turn around and use those points to spend on Gradle swag or Legos or other rewards that we have on the platform. We're adding new stuff all the time. This is a great way to just kind of self-paced, like on your own, go and kind of learn more about DPE in ways that you can bring back to your organization in a way that's self-paced that will actually reward you for that participation. So really excited about our new advocacy hub, and you can join here. You'll go through the initial kind of DPE journey, and then we'll dump you into the larger advocacy platform, which continues with weekly challenges and other fun stuff. If you don't care about rewards, but you do care about badges, there are absolutely badges. There's a whole gamification element to this. That's really it. Thank you, Nate, as always, and thanks to the Spring team. Looking forward to Spring 1. And of course, feel free to reach out if you have any other questions or you just want to talk about this stuff.
Well, heck yeah. Thanks, buddy. I appreciate your time today. And I did see Fuel Snable joined us and said, I'm a 10% developer. I disagree with that, Fuel. You're at least 12 or 13%, don't you think? I mean, come on. I also want to say my neck hurts a little bit because I was like violently shaking my nodding along as you went, and a lot of good stuff in there. And I mean, when you're talking about this being creative field, I just don't think we get enough credit for that.
I agree.
And I was talking with some of my friends last week about this. Code is very good at getting into that flow state, and we've all had that experience of you look up, you're like, oh geez, I've been working on this for like 2 hours. I should get up. And my watch told me I need to stand. And I think anything we can do to improve that is a win. So yeah. I did have a build once that took a day to complete. It was 24 hours.
Wow.
Yeah,
the Apache Tika project, its full corpus of tests takes over 48 hours. So there you go. Yeah.
Wow.
Yeah.
So, no, it's good stuff. And I especially like the bit about, flaky test, we ran it, it worked. And then you don't think about it. You might realize, well, wait a minute, that test is flaky a lot. And for a lot of people, we might want to investigate that, but you don't think about it when I got to move on to my next thing. Having some of that visibility to me is just huge. So
put it on a dashboard. Once it's on a dashboard, it's actionable.
Yeah.
In fact, we know our own build tool, Gradle Enterprise team, and the Gradle build tool engineers, as well as a lot of other highly productive organizations, they schedule flaky test days where they just open up this dashboard, click sort by flakiness, and just eliminate. So there's you have the data, and then you make that data actionable by scheduling a flaky test day.
Oh, heck yeah. Well, Justin, I know you and I could probably talk for another 2-3 hours. I know you've got to mosey along, so I will wrap this up. I will also remind everybody, if you're into this Spring space and you want to learn more about Spring, go to Spring Academy. We got a bunch of on-demand stuff there. You can get yourself certified. You can see Josh's smiling face. Isn't that fantabulous? And as Justin mentioned, we do have Spring 1 coming up at the same place you are. You might as well just stay there till August.
I don't know if I would survive that, Nate, to be honest with you.
I mean, you might not, and your wife might have some opinions on that.
Yeah, I think so too. But we'll be back. We'll be back for Spring 1. So
heck yeah. Well, thank you very much, my friend. A pleasure as always, and thanks everyone for joining us here today. We had a great group that was on there. If you have other questions, by all means, please reach out to Justin. He is an excellent human being, one of my dearest friends, and I cannot wait for you and I to be in the same meet space, my friend. So
likewise, Nate. Likewise.
Thank you very much.
Take
All
care.
right, cheers, buddy.
Cheers.